Imagine Paris, late evening, 1785. Dim candlelight flickers across glass flasks and copper scales in a laboratory. Antoine Lavoisier, often called the father of modern chemistry, meticulously weighs his reagents down to the tiniest gram. He's not just experimenting, he's proving. Proving that matter neither disappears nor appears from nowhere. It simply changes form. He looks at these flasks, at these solid, tangible substances, and feels triumphant. The world is understandable, stable, made of unchanging building blocks. No surprises, it seems. He, and the whole world after him, believed. Believed in an unshakable, tangible, concrete reality. Hey, if you're already intrigued about where this is going, and you enjoy having your worldview shaken up a bit, or a lot, don't forget to subscribe to the channel and like this video. It really helps us create new content. And by the way, we're super curious. What city and time zone are you watching our lectures from? Let us know in the comments. We'd love to see the geography of our audience. While you're typing, let's get back to our story. Lavoisier's world was a world of certainty, a world where matter was matter, period. But what if I told you that this certainty, this unshakable truth about a solid world, is just one of the most grand and convincing illusions in the universe? What if everything you see, feel, touch, this table, your phone, even your own hand, is nothing more than a brilliantly staged performance? Scenery made of pure energy, so artfully arranged that our brains perceive it as something absolutely real and solid. I get it. Your brain is probably saying right now, hold on, what nonsense? I can feel this chair, it's solid. And that's a perfectly normal reaction, because our whole lives, from the cradle, we've been told, this is reality. We grow up in a world where a rock is a rock, water is water, and air is just the emptiness in between. It's our default operating system. But you know what's most amazing? Physics, the very science meant to explain the world and make it more understandable, at some point started raising such questions that even the most seasoned professors would drop their glasses. It started hinting that our solid reality is like a giant billboard. You look at it, see a beautiful picture, bright colors, text. It seems like something whole and dense. But what if you get closer, examine the graininess, and see that it's just billions of tiny dots of light playing with your perception? It's much the same with matter. We live in this magnificent, convincing three-dimensional picture. We think it's made of unshakable things. But what if all these things are just very, very dense, energetic clusters that vibrate at a certain frequency and create the illusion of form and mass for us? It's like a hologram so perfect that you try to touch it. And to your surprise, it actually feels solid. Imagine a magician. He shows you an empty cylinder, and a second later, a rabbit appears from it. You know it's a trick, but your eyes still don't believe it. Now, imagine the universe itself is such a grand magician, showing us a rabbit, that is, matter, but really working with pure energy that we don't even see. And all this matter is just a temporary rabbit pulled from a hat. So, get ready. Because we're about to dive into the deepest reaches of quantum mechanics and relativity. To a place where Lavoisier might have laughed at first, then been utterly amazed, and then perhaps even wondered himself, perhaps my matter is just energy in a masquerade costume. This journey won't just change your view of the world, it will turn it upside down. And you know what's most exciting? This isn't science fiction. This is science. Imagine a hot day in the Agora in Athens, sometime in the 6th century BC. The sun beats down mercilessly on the backs of philosophers as they debate the nature of existence. Pythagoras, perhaps off to the side, sketches out his ideas about the harmony of numbers, about how the universe is a giant mathematical formula. But even he, with all his abstractions, looked at the marble columns of the Parthenon and saw marble. He picked up a clay jug, felt its weight, its solidity. No one could have imagined that this solidity was just the tip of the iceberg, and beneath it lay something entirely different. By the way, if you're already intrigued about how we're going to shatter your conventional views of the world, don't forget to like this video and subscribe to the channel so you don't miss the next dose of mind-blowing discoveries. And please tell us, what city and time zone are you watching our lectures from? We'd love to know the geography of our curious listeners. While you're typing, let's get back to our story. Listen, it's perfectly natural. We humans see the world through our five senses. We touch something, and it's solid. We kick a rock, and it doesn't move. If you stand by a wall, you can't walk through it. Our ancestors, living thousands of years ago, couldn't have survived if they hadn't believed in the reality and immutability of surrounding objects. For them, a cobblestone was a cobblestone, period. Imagine, you're an ancient hunter. You need to know that the stick you're holding will hit, not dissolve into thin air, that the tree you're climbing will support your weight. Otherwise, game over. Sorry for the modern slang. And this fundamental belief in the solidity and tangibility of everything around us was passed down from generation to generation. The philosophers of ancient Greece, of course, pondered the primal elements, what the world was made of. The four elements, earth, water, air, fire. Sounds logical, right? Each element is perceivable and understandable. Earth is solid, water is liquid, air is gaseous, fire. Well, it burns. No quantum fields or vibrating energies for them. Everything was simple and clear. Then came Sir Isaac Newton, with his apples falling on heads and laws that governed everything, from the movement of planets to that very apple. Newtonian mechanics described the universe as a gigantic, incredibly complex but still a mechanism, a clock whose gears were small, solid, indivisible particles. An imaginary skeptic might say, so what? It all makes sense. If I throw a billiard ball, it hits another ball. Everything's solid. Exactly. Newton's world was a world of billiard balls. Each particle had its place, its mass, its speed, and we could predict its movement. It was a triumph of human reason. We could understand how the world worked, or at least so it seemed. This view of the world as a collection of small, solid objects from which everything else is made became firmly rooted in our consciousness. From school textbooks to everyday experience. We can't walk through a table, right? It's solid, it's real, period. We lived in a world where everything seemed so fundamental. It seems there's nothing more understandable than this sturdy, reliable foundation of matter's building blocks. But what if I told you that this solidity is just a very, very convincing marketing ploy by the universe? That behind this visible firmness lies something much more ephemeral. Something that will make you reconsider everything you've held to be unshakable. You see, our belief in solid truth is our cultural, historical, and even evolutionary anchor. We clung to it for millennia because it gave us a sense of control, predictability, and it worked. Until people started asking very inconvenient questions and looking inside those solid building blocks. And what they discovered there shocked everyone, including the researchers themselves. Imagine Berlin, the year 1900. Kaiser Wilhelm II proudly reigns over the German Empire, and a similar self-satisfaction prevails in the minds of scientists. Lord Kelvin, one of the most respected physicists of his time, had declared just a couple of years earlier that almost everything in physics had been discovered, with only 2 small clouds remaining on the horizon. These clouds, well, you know, like tiny specks on perfectly clean glass that you're about to wipe away, and then everything will be perfectly clear. Physicists felt like they were on top of the world. They had explained the movement of planets, falling apples, the properties of light. It seemed the universe had revealed all its cards to them. Yes, so it seemed. If you're already curious where these clouds will lead us, don't forget to like and subscribe to the channel so you don't miss our other fascinating journeys. And please tell us, what city and time zone are you watching our lectures from? We'd be very interested to know how far this whisper from the void travels. But these clouds, my friends, turned out to be more than just little wisps. No, they were harbingers of a storm that would turn the entire scientific worldview upside down. Imagine, physicists are sitting around, sipping their coffee, thinking life is good, and then, boom, light. That very light, which everyone considered an absolutely undeniable wave, like an ocean wave, but in the ether, suddenly started behaving like a particle. Yes, like a tiny solid ball of energy, a photon. Physicists were like, "What nonsense? Are you serious? This is absurd. How can something be both a wave and a particle at the same time? It's like your cat suddenly becoming both a liquid and a brick. Impossible." Just like that, out of the blue. And then the really interesting stuff started, with electrons. These seemingly solid building blocks of atoms, these microscopic planets orbiting the nucleus, they started pulling such stunts that heads were spinning. Sometimes an electron would just disappear from one place and reappear in another, as if teleporting without even passing through the space in between. You understand? It's like you close the door to one room and your child disappears from there and reappears in another without opening doors or walking down a hallway. But that can't be. It defies common sense, you might say. That's exactly what scientists thought. This was the first deafening warning that our world, with all its tables, chairs, and solid walls, wasn't so simple after all. It turned out to be far stranger, more intriguing, and much less solid than we used to think. The quantum age was beginning, and it whispered of great mysteries from the very depths of the void. 1911, Manchester, UK. Imagine a small laboratory buzzing with tension. Ernest Rutherford, a stern yet insightful physicist, along with his young colleagues Hans Geiger and Ernest Marsden, conducts a seemingly simple experiment. They're firing alpha particles, microscopic helium nuclei, at a thin sheet of gold foil. The idea is straightforward. If gold atoms are dense spheres, as was believed at the time, remember Thomson's plum pudding model, then the particles should pass right through them, perhaps deflecting only slightly. But what happened? Most of the particles did pass straight through, but some, to the scientists' complete shock, bounced right back. It was like shooting a machine gun at tissue paper, and the bullets ricocheted back. This was the moment when physicists dropped their teacups and said, "Hold on, something's not right here." Rutherford would later say it was almost as incredible as if you had fired a 15-inch shell at a piece of tissue paper and it came back and hit you. Before we delve deeper into this bottomless void, if you're enjoying this journey through the strangest corners of the universe, don't forget to like this video, and subscribe to the channel. Your support helps us create even more engaging stories like this. And tell us in the comments, what city and time zone are you watching our lectures from? We'd be very interested to know how far our scientific community reaches. So, what did this tissue paper, reflecting cannon shells, lead us to? A shocking conclusion. The atom is not a dense sphere. It is, imagine this, almost absolute emptiness. 99.999% emptiness. You know, it's like if you took an entire football stadium, a huge arena, stands the pitch, and right in the center of that stadium, precisely on the penalty spot, lies a tiny pea. That pea is the atom's nucleus, and the entire stadium, with its enormous volume, is the area where electrons fly. Electrons are so tiny and move at such speeds that they're better imagined not as tiny planets orbiting a sun, but as blurry clouds of probability. They're not in one place. They're everywhere at once, until you look at them. Wait, the skeptic might say, but if it's all emptiness, why don't I fall through my chair? Why doesn't my hand pass through the table? Excellent question. And the answer is as astonishing as the emptiness itself. The thing is, even though an atom is mostly nothing, its outer edges are those very electrons. And these electrons, while not solid in our conventional understanding, possess an electrical charge. Like charges repel, remember? Your hand doesn't pass through the table not because the table's atoms are solids, but because the electrons in your hand and the electrons in the table repel each other. It's as if you're trying to push two magnets together with like poles. They won't let you, even if there's empty space between them. It's not the table holding you up, it's the force of repulsion between invisible energy clouds. Let's go further. Those very particles that make up the nucleus, protons and neutrons, and even the electrons themselves, they're not really particles in the conventional sense, not tiny billiard balls. Modern physics tells us they are more like excitations or vortices in certain invisible fields. Imagine a vast infinite field, like an ocean, and particles are waves on that ocean. Sometimes they appear as individual crests, particles, sometimes as ripples across the entire surface, waves. It's not something that is, in a strict sense, but rather a manifestation of energy. These aren't the building blocks the world is made of. They're more like musical notes played on the strings of the universe, vibrations, energetic clusters that we perceive as matter. Your mug on the table, it's not a pile of microscopic pebbles. It's a dense collection of tiny energetic vortices that are constantly dancing, vibrating, and repelling each other, creating the illusion of solidity. So when you look at any object, remember, you're not seeing a dense, static thing. You're looking at an incredibly fast, complex, and almost entirely empty dance of energy. The atom, this basis of everything, is a masterpiece of minimalism and optical illusion. Emptiness that appears dense, energy that appears as matter. Astonishing, isn't it? Imagine the 17th century, London. A winter evening, candlelight casts whimsical shadows on the faces of curious gentlemen of the Royal Society. At the center of attention is Robert Boyle, the great experimenter. With a distinguished air, he starts his famous air pump. Heavy metal groans, the piston moves, and the air, the very air we breathe, is evacuated from a glass flask. Boyle triumphantly demonstrates the flask is empty, inside it, a vacuum, a true pure nothingness created by human hands. Everyone applauds. "We have conquered the void," cries echo. They couldn't have imagined how grandly mistaken they were. Listen, if you like how we're turning your understanding of the world upside down here, don't forget to like and subscribe to the channel. Your support is our quantum engine. And by the way, what city and time zone are you watching our lectures from? Let us know in the comments. We'd be interested. Now, let's return to that nothingness. We, like Boyle, long thought, space is a cold, empty darkness. Between the stars, a silent abyss, absolute stillness. Like black velvet, without pattern, without a hint of life. That's the grandest misconception. Because in reality, it's teeming with invisible energy so much that your morning coffee cup, when you drop it on the floor, creates less chaos. Imagine an ocean. On the surface, calm, just a slight ripple. But look beneath the water. Life is teeming there. Billions of fish, seaweed, currents. Well, this empty space, it is that ocean. Only instead of fish, there are quantum fields. And instead of water, energy. And this energy doesn't just sit still. It constantly, every second, without interruption, gives birth to and absorbs so-called virtual particles. Virtual, the skeptic might say. What's this? Another physics invention to confuse us? And I'll tell you, it's not an invention. It's a reality confirmed by experiments. You know, these particles, electrons, positrons, photons, they're like ghosts. They appear from nowhere, live for a microscopic fraction of a second, and vanish, returning back into the energetic fabric of the vacuum. They're like flashes of lightning in utter darkness. They sparkle and disappear, appearing from nowhere, returning to nowhere. All this is explained by Heisenberg's famous uncertainty principle, which, to put it simply, states the more precisely you know one thing, like time, the less you know another, energy, or vice versa. And the vacuum exploits this. It sort of borrows energy for a very, very short time to create these particles, and then quickly pays back the debt when the particle vanishes. It's like you quickly pulled 100 rubles out of your wallet for a second to show a friend, and then immediately put them back. The money was seemingly there, but in reality, it wasn't, as it were. But these non-existent particles, they very much influence everything around them. They create pressure, they affect magnetic fields, they even change the properties of ordinary, real particles. This isn't emptiness. It's a whole symphony of quantum fields, constantly sounding, constantly changing, constantly creating. Space isn't silent. It whispers, it sings, it hums with energy. And these whispers, songs, and hums are just one way energy shows us that it never stops being the architect and designer of everything we perceive as matter. The vacuum isn't the absence of everything. It's a bubbling cauldron of pure potential. It's the foundation of all that is. You understand? Even where there seems to be nothing, life is actually teeming with pure energy. Listen, 1905, a hot September day in Bern, Switzerland. The streets hum with voices, the smells of fresh pastries and horse manure. People rush about their business, completely unaware that right now, in a dusty patent office, a young and still unknown Albert Einstein is quietly turning the world on its head. He's finishing his work, and among other brilliant papers, something is born on paper that will forever change our understanding of the universe. More precisely, 3 letters, an equal sign, and a couple of numbers that essentially declared, "Your precious matter." Why, that's just dormant energy, just waiting for the moment to awaken. And before we continue this incredible journey through the depths of quantum physics, if you like what you're hearing and seeing, please don't forget to like this video and subscribe to our channel. It really helps us create even more engaging and informative content. And please tell us, what city and time zone are you watching our lectures from? Let us know in the comments. We'd be interested. Now, let's return to our genius. Imagine, before Einstein, physicists lived in a relatively cozy world where matter was one thing and energy was something else entirely. They were like two separate nations with different currencies. They could exchange, but never merge. And then this short but incredibly powerful formula appears. E=mc2, and the world explodes, both literally and figuratively. What does it mean? Oh, it's not just a mathematical equation. It's a manifesto. It says that mass and energy are two sides of the same coin, like heads and tails. They're not just related, they are identical. Mass is simply a very, very concentrated form of energy. And energy is mass that isn't sitting still. Hold on. I hear your inner skeptic. You're saying my coffee cup is a lump of energy? And if I break it, there'll be a nuclear explosion? Well, almost. Not exactly. Imagine you have a giant battery, but it's sealed in a concrete cube, and you can't use it. Well, matter is like that concrete cube, with an incredible amount of energy inside. It's there, just hidden. The C2 coefficient in the formula is the speed of light squared, a number so enormous, 300,000 kilometers per second multiplied by itself, that even a tiny mass contains a mind-boggling amount of energy. That's why even a microscopic amount of substance can cause a grand explosion, like an atomic bomb. It's not magic, but simply a process where part of this dormant mass converts back into pure, free energy. Listen, it's like taking a giant block of ice. It seems solid, unmoving, but if you heat it, it turns into water, and then into invisible steam that can power turbines or disappear into the sky. Mass is like that frozen energy potential, and E=mc2 is the recipe for unfreezing it. Physicists before Einstein were like, okay, we have a brick, it's heavy, and we have lightning, it's powerful. These are different things. But Einstein came along and said, no guys, both the brick and the lightning are just different manifestations of the same essence. A brick is energy that's spending its time very, very slowly. Lightning is energy that decided to throw a party. This was more than just a scientific discovery. It was a philosophical earthquake. If matter is just incredibly densely packed energy, then our entire world, everything we see and touch, from stars to our fingertips, is a grand, majestic dance of energy, frozen in various forms. This means the universe isn't made of things, but rather of processes, of pure dynamic vibrations that we interpret as stable objects. This changes everything. If there's no solid matter in the conventional sense, but only flows and fields of energy, then what does that mean for our reality? What do we see when we look at the world? And even more interesting, what happens when we look at it? If matter is merely dormant energy, then we ourselves, with all our senses, perceive only its external manifestations. We see the shadows of the dance, not the dance itself. And this is where it gets really interesting. If the world is energy, couldn't we ourselves influence how it manifests? Imagine, autumn 1927, Brussels, the 6th Solvay Congress. 29 of the greatest minds on the planet, among them Einstein, Bohr, Planck, Schrödinger, Heisenberg, sit around a table in an atmosphere that smells of strong coffee, cigar smoke, and utter bewilderment. They're not discussing war or politics. They're trying to figure out how, for crying out loud, reality works. Formulas on the board, tension in the air, and then one of them, likely Niels Bohr, says something that makes Einstein sigh deeply. A particle has no definite position or velocity until it is measured. Imagine how old-school physicists might have reacted to that. What nonsense! The clock on the wall exists even if I'm not looking at it, some hypothetical 19th century professor would have protested. But reality turned out to be far stranger than the wildest fantasies. Before we completely lose our minds in the quantum depths, please, if you're enjoying this dive into the mysteries of the universe, like and subscribe to the channel. It helps us create more content like this. And tell us, what city and time zone are you watching our lectures from? We'd be very interested to know where our listeners are. Now, let's return to our schizophrenic particle. All right, here's the really wild stuff. What we're discussing now isn't just philosophical speculation. It's the result of thousands of real experiments. The most famous is the double-slit experiment. 1927, experimental physicists Davison and Germer fire electrons at a barrier with two slits. What happens? If electrons are particles, they should pass through either one slit or the other, leaving two distinct spots on the screen behind the barrier. Logical, right? But no. When scientists aren't looking, that is, not detecting which slit each electron passes through, they behave like waves, creating an interference pattern, multiple bands, on the screen. It's as if each electron simultaneously passed through both slits and interfered with itself. You know, it's like throwing tennis balls at a wall, and while you're not looking, they turn into water waves passing through two arches of a bridge, and then reaching the shore, become balls again. Absurd? Yes, but that's what happens. The quantum world doesn't like being alone. It's like a shy child who only starts behaving well when someone is watching. But here's the craziest part. As soon as you try to find out which slit the electron passes through, by setting up a sensor, for instance, what happens? The wave nature disappears. Electrons, again, behave like particles, passing through one specific slit and leaving those very two bands on the screen. Just our gaze, our measurement, our attempt to gain information. And the particle, like an actor on a stage, changes its behavior. It collapses from all possible states into one definite state. This isn't just observing something already existing. It seems to be creating reality at the moment of observation. Many physicists are still scratching their heads over this. Einstein, for example, could never come to terms with it. His famous "God does not play dice" was precisely about his unwillingness to accept this quantum uncertainty and the role of the observer. He believed there were hidden variables that we don't yet know, but so far, no hidden variables have been found, and experiments only confirm. Our reality, at its most fundamental level, is very much like a computer game where textures only load when the player turns to face them. We're not just spectators in the theater of the universe. We, it turns out, are also scriptwriters, co-creators, and that's hair-raising, because this isn't just about a particle. It's about our entire reality. Imagine the scorching dawn of July 16th, 1945, the Alamogordo Desert, New Mexico. The air is heavy, tense. Dozens of scientists, engineers, and military personnel hold their breath. A moment later, precisely at 5:29:45 a.m., the world would change forever. The sky would be torn open by a blinding flash, brighter than 1,000 suns, and a mountain-sized mushroom cloud would rise above the ground. This wasn't just an explosion. It was a grand, terrifying, yet magnificent proof. Matter and energy are two sides of the same coin, and one can transform into the other with incredible, almost divine power. By the way, if you enjoy cosmic journeys like this across the edges of reality, don't forget to subscribe to the channel and like the video if you enjoy it. And please tell us, what city and time zone are you watching our lectures from? We'd be very interested to know. Now let's return to that dazzling dawn and its implications for our understanding of the universe. Einstein, with his EUMC2 formula, showed us that mass is concentrated energy, and the Alamogordo explosion vividly demonstrated this. But if matter can transform into energy, can't the reverse happen? Can the universe create matter from pure energy and then entire stars, galaxies, and even ourselves? Listen, if you were the universe's chef and you only had one ingredient, pure energy, how would you cook up stars, planets, and eventually a complex dessert like life? What? Just like that? Out of nowhere? Without a recipe? A skeptic might ask. Well, almost. Imagine a cosmic broth. Not soup, but broth. Transparent, yet full of hidden potential. This isn't the vacuum we imagine as empty, no. It's a boiling, seething substance of quantum fields, which we discussed in the previous section. These fields constantly vibrate, fluctuate, like the surface of a very sensitive lake. And you know what? Sometimes these fluctuations become so strong that they literally push particles into reality. It's like ripples on water that suddenly freeze into an ice crystal. And so, our chef, that is, the universe, begins its grand dance. In the very beginning, right after the Big Bang, the universe was exactly such an energy soup, incredibly hot and dense. With each fraction of a second, it expanded and cooled. And as it cooled, this energy began to condense. Imagine you're mixing water with sugar syrup. At first, it's all liquid. But if there's a lot of syrup and it cools, it starts to crystallize, forming solid pieces. It's the same here. Energy condensed, turning into elementary particles, quarks, leptons, and then more. These particles combined. Quarks into protons and neutrons into atomic nuclei, mostly hydrogen and helium. But how did stars emerge from this gaseous nebula? Here, gravity comes into play. This invisible but omnipotent force begins to pull these scattered clouds of hydrogen and helium together. Think of it like a giant cosmic vacuum cleaner. It slowly but relentlessly gathers all the tiny gas and dust particles in one place. As the matter is pulled together, it becomes denser. Pressure rises, temperature skyrockets. Millions, billions of tons of gas compress under their own weight. And at some point, inside this collapsing cloud, it becomes so hot that hydrogen nuclei begin to fuse, forming helium. This is called thermonuclear fusion. Hello, star. And this isn't just a flash. It's a huge, constantly burning furnace that continuously transforms matter, hydrogen, back into energy and helium, releasing it as light and heat. Wait, so it transforms matter into energy? But we're talking about how to make matter from energy, my imaginary opponent might exclaim. And they'd be right. But that's the beauty of it. The universe isn't a one-way street. It's an eternal cycle. Energy becomes matter. Matter becomes energy. Stars are gigantic factories that don't just shine. They create. From hydrogen and helium, they synthesize heavier elements, carbon, oxygen, iron, all the building blocks we're made of, our planets, everything around us. All of this is essentially reprocessed energy that once danced as quantum fields, then condensed, solidified, ignited, and exploded to scatter these elements throughout the galaxy. Imagine, you carry within you particles of energy that once shone in the heart of an ancient star. You are literally stardust, animated by energy. What's that like? To realize that you are the product of a grand cosmic dance where energy and matter endlessly change their forms. December 28th, 1895, Paris, Grand Café, Boulevard des Capucines. Picture this scene: the dim light of gaslights, the creak of chairs, the scent of coffee and cigars. People, most of whom had never seen moving images, sit holding their breath. A train appears on the screen, and it's rushing right at them. Screams of terror, panic. Some jump up, trying to dodge it. This was the Lumiere brothers' first public film screening, and for these people, reality collapsed for a moment. Their brains couldn't distinguish the projection from a real threat. Before we delve deeper into this puzzle, if you like what you're hearing, and this conversation makes your neurons dance, please subscribe to our channel and like this video. It helps us create even more engaging content. By the way, we're very interested. What city and time zone are you watching our lectures from? Write in the comments. We'd love to learn about our community. Now let's return to our train, which isn't rushing, but still changes our understanding of the world. That train, that moment when illusion became indistinguishable from reality, is mere child's play compared to how our entire universe plays with us. You understand? We talked about how matter is 99.999% emptiness, and the remaining particles aren't solid balls, but vortices of energy, quantum fields in a constant dance. Oh great, the Matrix again, you might say. That's just science fiction, Keanu Reeves and all that? And yes, and no. The film is, of course, a metaphor. But quantum physics shows us that the very foundation of our reality might be far more fluid than any Hollywood script. Imagine you're living in a computer game. Everything you see, feel, hear, it's pixels, code, data. But you feel pain, joy, love. To you, it's absolutely real. So what if our world isn't so much the Matrix, where there's some external force controlling us, but rather the universe's own macro? A macro isn't just a program, it's the rules. It's a set of instructions by which energy transforms into what we call matter. These instructions say, hey, this energetic vibration will now appear as a stone, and this one as a tree, and these special vibrations will become you, a human with consciousness capable of asking questions about your own nature. Our body, our thoughts, our emotions, all are manifestations of energy, pure, vibrating energy, a feeling of love, an energetic pattern, fear, another pattern, your hand holding a coffee cup, an interaction of energetic fields, creating the illusion of density and tangibility. You know, when we talk about a perception reboot, it doesn't mean the world will disappear when we clap our hands. The table will remain a table, but our understanding of its fundamental nature will change. It's like realizing that a photograph isn't the person themselves, but just their projection. The photograph is real, but it isn't the whole person. We aren't just lumps of flesh and bone. We are complex, unique energetic structures interacting with other similar structures. We vibrate. We dance in this vast energetic field of the universe. And our thoughts, our intentions, they are also energy, which, like any other quantum vortex, can influence the surrounding reality. Remember the observer principle? When a particle decides how to behave only when we look at it, what if our consciousness, this highest form of energy organization, also participates in this process? What if, by realizing the illusory nature of matter, we gain access to a deeper layer of reality, where we are not just spectators, but active participants in creating our own world. This isn't esotericism, not magic. These are the conclusions that cutting-edge physics leads us to. We are much more quantum than we thought. Our sensations, our touches, our sense of self, this is a complex, multi-layered, yet very convincing illusion created by energy. And if that's true, then the boundaries between the internal and external, between subjective and objective, begin to blur. And that, is simultaneously frightening and incredibly liberating. Because if you are energy, and not just matter, then your possibilities are limitless, like the energy you are made of. An illusion, perhaps, plausible, definitely. But most importantly, you are a part of it. Imagine Paris, 1874. An exhibition opens in a studio on Boulevard des Capucines that would forever change the world of art. The scent of turpentine mixes with the aroma of spring in Paris. The paintings seem unfinished. On Claude Monet's canvas, titled Impression Sunrise, you see not the clear outlines of the port of Le Havre, but merely a play of light, soft brushstrokes of orange and blue. Critics are furious. It's just an impression, they shout, because they were accustomed to clear, tangible reality, to solid lines and forms. But suddenly they were offered a different reality, fleeting, breathing, woven from light and a moment. But it was precisely this illusion that gave birth to one of the most beautiful movements in art, showing that truth is not always hidden in literalness, but sometimes in the ability to capture the very heart of the moment. Listen, if you, like us, enjoy diving into these incredible stories about how our world works, don't forget to subscribe to the channel and give us a like. It helps us create even more engaging content. By the way, we're very interested. What city and time zone are you watching our lectures from? Let us know in the comments. We'd be interested. Now let's return to our own grand and sometimes shocking picture of reality. So if our world, this massive structure of matter, is actually just a masterfully performed symphony of energy, then why, one might ask, such an elaborate illusion? Why do we have this stunning masquerade? You might say, so what if my chair is dancing vortices of energy? I still feel it. It's solid. And you'd be right. Our brain, our mind, it's also a part of this universe, and it's wired to perceive the world exactly this way. Convenient, stable, predictable. Imagine you're a director creating the most epic and captivating film in history. You can't just show the actors a script and say, now act out emotions. You build sets, create costumes, write dialogue so they feel their role, so the audience believes. And perhaps our universe does the same. It creates this convincing illusion of density, of tangibility, so we can experience life, feel it. So our stories, our joys and sorrows, are truly profound, not just an abstract dance of energies. You see, it doesn't mean our senses deceive us, not at all. It means they are incredibly sophisticated tools for interpreting the most complex energetic information. Like a computer monitor isn't the reality of a film, but it allows you to see it, hear it, experience it. And beneath the surface of that monitor are billions of electrical impulses, zeros and ones. Perhaps all this solidity and matter is simply an interface. A convenient user interface for our complex biological system, so we can interact with this vast, dynamic, bubbling ocean of energy without going crazy from information overload. Imagine if you were aware of every single quantum fluctuation around you every second. It's like trying to read a book while seeing every individual molecule of ink and paper. simply impossible. So why is this a beautiful illusion? Because it gives us structure. It gives us a stage on which we can play our roles, to love, to suffer, to create, to explore. Without this convincing yet illusory density, our world would be just a chaotic blob of energy. But the universe, like a great artist, took this pure energy and sculpted from it mountains and oceans, stars and galaxies, and ourselves. It's similar to how a great chef takes simple ingredients, flour, water, yeast, and transforms them into fragrant bread. The ingredients themselves are simple, but their interaction and transformation create something much greater, something that nourishes and delights. Likewise with energy, abstract in itself, but its transformation into matter creates all the complexity and beauty we perceive. And realizing this doesn't devalue our lives. Quite the opposite. It adds a new dimension to it. Now you know that you're not just a lump of flesh and bones. You are a complex, constantly changing energetic vortex, part of a grand cosmic symphony. You are a unique manifestation of this pure energy, capable of awareness, creation, love, and asking questions about the meaning of it all. This knowledge isn't an end, but a beginning. It opens doors to a new understanding of yourself and your place in the universe. It allows you to view the world not as a frozen, dead backdrop, but as a living, breathing, constantly transforming field of possibilities. And that, you'll agree, is a far more exciting and beautiful reality than mere solid atoms, isn't it? Because in this illusion, we are not passive spectators, but active co-creators, whose every thought and action perhaps echoes in the infinite quantum fields. Isn't that the most beautiful thing one can imagine?